First thing I want to discuss, velocity time graph. How do you do that? How do you sketch your velocity time graph? From the name, velocity time graph, okay, velocity time graph. How do you do that? How do you sketch it? Okay, for velocity time graph, you are going to have velocity on the vertical, okay, and then you put the units by the side, meter per seconds, velocity on the vertical, and then the time on the horizontal, your time on the horizontal in seconds, your time on the horizontal. I can do it here. So velocity time graph, you can see what we have here. You can see your velocity on the vertical. The unit must be mentioned. If you don't put the unit there, we won't give. And then the time on the horizontal, you can see also it's measured in seconds. Okay, let me quickly take you through this diagram. Okay, velocity on the vertical, time on the horizontal for velocity time graph. Okay, and then you can see a body start on rest. The body start on rest, and this is the position of acceleration. It accelerates. Okay, this is your acceleration. This is where you have your acceleration. It accelerates for what? For certain time. Okay, and then it maintains that speed. Line AB is a constant speed. Acceleration is 0 in that place. Okay, acceleration is 0, and this place is the retardation. This is where we have our. That's where we have retardation. Okay, when the body is coming to rest, that's retardation, acceleration, retardation, and then constant speed. Okay, so that's that on that case. Then the next thing to do now, how do we get the distance, the total distance from velocity time graph? Very simple. What you do is to look at the geometry. Look at the what? Look at the geometry of the shape you have. Okay, we said here that the total distance can be obtained by finding the area of the trapezium. If you see these geometry, this is a trapezium OABC. Okay, by finding the area of the trapezium. Okay, by finding the area of the trapezium. Trapezium could be, you could have in trapezium, you could have two triangles, and one rectangle, as the case it is in this question. Two triangle and one rectangle. Okay, that will make your trapezium. Or you could have one triangle plus one rectangle. Okay, that's how you can get your that's the shape for the trapezium. Okay, so for this example, for total distance, you look at the shape, and the shape we have here is trapezium. And the formula for trapezium is half times a plus b times h. Distance, the total distance for trapezium is half times sum of parallel sides. Sum of what? Parallel sides. One is here, AB. That's one parallel side. That's why we said half AB plus another parallel side from here to here, OC. And then times the height. This is your what? This is your height. Okay? That's your height. So that is one way to calculate your what? To find the total distance. Okay? By looking at the geometry using the area of a trapezium. In this case, we have a trapezium. Okay, so that's that on that. We can as well take it individually. Look at the shape individually. I can call this one 1, call this one 2, call this shape also 3. Okay, get the area of 1, get the area of 2, get the area of 3, and then for the total distance, you now sum it together. You now add it together. So let's get the x1. That'll be half. Base is OA. Half times OE. Half times OE, and then times what? Times the height. That's our AE. Okay. The distance for this geometry for 2 is rectangle. This is a rectangle, and that will be equal to what? Length times width. Okay, and that will be equal to what? ED times what? Times either BD or AE, because AE and BD, they are parallel to each other. They are parallel to each other. They are the same. Opposite side of rectangles are equal. So that will be what? BD. And finally, the third shape, my base is DC times what? The height is what? BD. So once you get the geometry of the first shape, second one, geometry of the third one, then you add the distances together, and that will be the total distance. That will be the total distance. Okay, so that's that on that case. That's that on that case. And don't forget what I said here. There is a speed attained at this place, which I call V1, and that speed, it maintains it, okay, at a constant speed. The speed is constant, and when the speed is constant, acceleration is 0. Acceleration is 0. Okay. The next thing to do now is to look at question. We have these speed time graph. We have 9 in this place. This is the origin. We have 4 here. We have 12 here. This is time. The diagram shows the speed time graph of the motion of an athlete running along a straight track. Okay. For the first 4 seconds, you can see he accelerates uniformly. This acceleration for the first seconds. The athlete accelerates uniformly from rest to a speed of 9 meters per second. And then the speed is then maintained for further 8 seconds. Okay. Find A, the rate at which the athlete accelerates. B, the total distance traveled by the athlete in 12 seconds. The total distance traveled by the athlete in 12 seconds. Okay, so the first one, we are told to find the rate at which the athlete accelerates. Okay, and I've told us that acceleration is gotten from here. The moment the body starts on rest, then it begins to accelerate. Then acceleration has this formula, change in velocity over time, which is the final minus initial. Final velocity minus initial velocity. Okay, in this case, this is initial, which is 0. This is final, which is 9. So that's 9 minus 0 over what? The time for that acceleration. You can see from the question, they said for the first 4 seconds, he accelerates uniformly from rest, okay, to a speed of what? 9 meters per second. Okay, so the difference in the speed is 9, and it does that in 4 seconds. It does that in 4 seconds, and that will be equal to 2 points, maybe 1, 0, 2.25. I think 2.25 meter per second squared. Means that the total distance traveled by the athlete in 12 seconds, total distance. I've told us that when you're looking at total distance, you can solve it in 2 ways. You can use trapezium method. You can use the geometric of individual shape. The first one is a triangle. The second one is what? Is rectangle. Let me call this one 1. Let me call this one 2. So I'm going to use the geometry of the shape. So the total distance is going to be equal to x1, and let me that will be 1 plus 2. The geometry of 1 plus 2. The geometry of 1 is a triangle, and that will be half base times height, plus the second one is rectangle. That's a length times breadth, or length times width. Okay, and that will be equal to half times my base is here for the triangle, from here to here. That's a 4. That's the base. My height is what? Is here. This is my height. That's my height, which is a 9. Okay, and then plus for the second shape, the length will be distance here from 4 to 12. Find the difference there. That's 8. The interval from here to here. Find the interval. That's 8. The interval is 8 times the breadth. That's here. That's a 12. That's 12. So that will give us that's a 114 meter. 114 meter. So that's the distance traveled by the athlete. If you don't want to use this method, you can use trapezium for way. The total distance, you can use this one, equal to half times the sum of the 2 parallel sides. We have 1 here. That's 1 parallel side. Okay, which is 8. I'm using this formula, half times a plus b times h. My a is this one, and then my b is from here to here, which is 12. That's my b. So a is 8 plus 12. The height is what? Is from here to here, which is 9. That's my height, which is 9. So this is going to give me 20. This is going to give me 20 times 9. So this is giving me this is 90 meter. So let's check this one. That's a 90 meter. That's 90 meter. The first geometry here, that's half base times height. Okay. Then this one here, that's 8 times 9. 8 times 9, sorry, is 8 times 9. This is the 8. Okay, that's the length. That's the breadth, which is at 9. It's not 12. It's 9 here. Okay, so this is going to be 72. 8 times 9 is 72. Okay, and that will be 90 meter. That's 90 meter. So whichever one you use, you must get the same answer. Whether you use a trapezium, okay, area of trapezium, or you find the area of the respective geometry, respective shape, you get the same answer. As you're coming in, just begin to say I. As you are coming in, just begin to say I. Okay? If you are new on this channel, please subscribe right now. Do subscribe now. Begin to call your friends, please. Energy is being given out. Call your friends. Call everyone to join us. Okay? Call your friends. Begin to share the links across your different platforms. We have a car is moving along a straight road. When t equal to 0 seconds, the car passes at point A with speed 10 meters per second, with speed 10 meters per second. And then the speed is maintained until t equal 30 seconds. The driver then applies the brakes, accelerates uniformly, coming to rest at a point B when t is 42 seconds. Sketch the speed time graph. Sketch the speed time graph to illustrate the motion of the car. Sketch the speed time graph to illustrate the motion of the car. B, find the distance from A to B. Find the distance from A to B. So this is the question. Okay, we have a car moving. Look at the statement here. When t is 0, underline that the car passes at point A with speed what? With speed 10 meters per second. Okay, this is time in seconds. This is your speed in meter per seconds. Then we are told something here. Then when t is 0, okay, when t is 0, the car passes at point A with what? With speed 10 meters per second. So this is a column for speed. This vertical line is a column for speed. This horizontal is a line for what? For time. Vertical for speed, horizontal for time. So when t goes to 0, the car passes at point A with speed what? With speed 10. So we can take our 10 to be somewhere here. So this is my 10 meters per second. Okay. When t is 0, okay, the speed is what? Is 10. Okay. And the speed is maintained. That speed is maintained for a certain time. That speed is maintained for a certain time and until t is what? 30. Okay, that speed is maintained until speed is what? Until time is what? 30. So your 30 could be somewhere here on this horizontal line is already seconds. Okay, and then the brake, the driver then applies the brake. The driver applies the brakes, okay, and the car decelerates. When you decelerate, that means the car comes to rest uniformly, okay, coming to rest at a point B. So this is point A, okay, this point A, this is a point this point B, okay. So the time is what? 42 seconds. 42 seconds. The car decelerates uniformly, coming to rest at a point B when t is what? 42. When t is 42. Sketch the time, the speed time graph. Okay, do your sketch. Sketch the speed time graph to illustrate the motion of the car, which we have done. Okay. The next thing we can do now, if we like, we can embolden it. We can make this diagram to be big. If you want to, you can make it big, but it's okay this way. It's okay this way. So we have done the A part. The B part, find the distance from A to what? To B. Find the distance from A to B. Find the distance from A to B. Okay, I'm going to use the trapezium formula. The distance, okay, that will be half times the sum of the two parallel lines. We have two parallel lines. We have one here from here to here, okay, and again from here to here. So from here to here is 10. And then from here to here is what? Is 42. Okay, and then times what? The height. The height is from here to here, which is what? 10. Okay, I'm using this formula, half A plus B times age. That's the formula I'm using. Okay, like, that is the that's what we're using this channel. Like, share, subscribe. Anytime I find something beneficiary, I always share it. I share it. Okay, don't keep it to yourself. Begin to share now. Call your friends and begin to share. So the answer will be equal to what? Half 10 plus 42, that's 52 times what? Times 10, and that will be 2 here 1, 2 here 5. That's 5 times what? 5 times 52, which will be equal to what? This one 0. That's 260 meter. That's 260 meter. In the sentences has been put into picture. We have the pictorial information, all the story here, all what you are saying here, all the sentences here, the summary just has been given here. Okay, so let's look at the question. The diagram shows the speed time graph, okay, of the motion of a cyclist riding along a straight road. She accelerates uniformly from rest to what? To 8 meters per second. When you accelerate uniformly from rest, you start from the origin. This is the what? This is your acceleration. Okay, it accelerates uniformly from rest. Okay, in 20 seconds. When you accelerate, then there must be time. You come down, and then there must be what? Reference speed for that journey. Okay, from rest to what? To 8 meters per second. This is the speed. Okay, and this is the time in 20 seconds. She then maintained this speed. She maintained the. She then travels at a constant speed of 8 meters per second for 40 seconds. It continued with that speed of 8 for what? For 40 seconds. Okay, do you know what you do? That 40, you add it to the first time. 20 plus 40, that's 60. Okay, so the interval between here is your 40. Okay, she then decelerates uniformly to rest in 15 seconds. She comes to rest. When you are coming to rest, just that triangle, that's a coming to rest in 15 seconds. 15 plus 60, that's what? That's 75. The interval here is your 15. Okay, and that's what we are going to use for your calculation. Okay, find A, the acceleration of the cyclist. Find A, the acceleration of the cyclist. Okay, in the first 20 seconds of the motion. In the first 20 seconds of the motion. B, the deceleration of the cyclist in the last 15 seconds of the motion. And finally, the total distance traveled in 75 seconds. So all this information has been put into picture for you. Okay, we have the pictorial information. This diagram summarizes all these sentences. Okay, that summarize all the sentences. What you just need to do, just for you to know, where can I get my acceleration, where can I get my deceleration, and how can I get my what? The total distance. Acceleration, this is the region of acceleration. When you start from rest, this is acceleration. This is where you can get your acceleration. This triangle will give you the acceleration. Acceleration has this formula. That's the acceleration is a change in velocity over time, which is what? The final minus initial over time. And you can get that from the beginning of the motion. It's start from the origin, it accelerates, and you attain the speed of what? 8. Okay, so that will be 8 is the final, initial is 0. So that's 8 minus 0. So over what? Over time. It does that the first 20 seconds. That's where you have your acceleration. The first triangle of the movement of the motion will give you your acceleration over 20. That's over 20, and that's what? That's 0.4 meter per second square. That's your acceleration. Then when you're talking of retardation or deceleration, that is when the body is coming to rest. Deceleration is when the body is coming to rest, and that can be gotten in this triangle. The last triangle will give you deceleration. The first triangle, you can get your what? You can get your acceleration. Okay. The last triangle, you can what? You can get your deceleration or retardation. So the second one, B, acceleration or deceleration. Okay. Actually, we expect to have a negative value. We expect to have a negative value for deceleration. How? I'll show you. The body is coming to rest according to the information. So when the body is coming to rest, your final velocity is 0, and then minus. Then at this point now, the velocity at this point, okay, before coming to rest, will now become your u. So that's what? That's 8, or what? The time for that deceleration, the question said it's 15 seconds of the motion. That's from here to here. The interval from here, that's the 15 seconds. Okay, so times what? Over 15. So that's minus 8 over 15. So deceleration must be negative answer of acceleration. Okay, calculator. So that will be equal to minus 8 divided by 15. That's a 0.5. That's a minus 0.5333 meter per second square. Then you can make it this way. The minus, take it to the other side. Minus acceleration is called deceleration, and that's equal to what? That's equal to 0.5333 meter per second square. That's a deceleration. Deceleration is negative acceleration, or we can say anytime you have deceleration, the value must be negative. Acceleration must be negative. Okay, so that's that on that case. That's that on that case. And I would want to say, you need a coach. You need a tutor. Okay, you need a tutor. Okay, for one-on-one or group discussion, check my channel for my email. You can meet me, you can send me email, then you can book a schedule for one-on-one or group discussion. For my email, check the comment section. I'll put it there. For my email, you can book appointments for tutoring, for coach. If you need a coach in any of your courses, send me email. Share the links of this video across your different platforms. Distance travel. Those two distance travel. What we're going to do for the total distance travel is going to be this is a trapezium, which is going to be what? Half times sum of the two parallel sides. Sum of the two parallel side. From here to here, get the interval there. That's 40 plus from here to here, that's 75, and then times what? Times the height. The height is from here to here, or from here to here. That's what? That's 8. Okay, and that will give you 4 times 11015, 75 plus 45. That's 120. 4 times 120. I think that's 480 meter for the total distance travel. Then you make a statement that the total distance travel is 480 meter. Okay.